Hi everybody, my name is Addie Cleary and I'm here representing Team 4 along with Jake, Clark, and Philip, and here's our evaluation report. A brief update from last week, we're now Team No Spoon, and in the spirit of the Matrix, our motto is do not try to win the final competition, instead try to realize there is no competition. To go back over the problem understanding very briefly, the first task to complete is to remove the Sentinel from the home zone. Then we're going to collect the programming modules and bring them back into our home zone away from the competition. Then we'll deposit the pills into the red zone and not the blue zone. And finally, once the shield is removed, we'll be retrieving Morpheus. And we'll also retrieve all of our subsystems from the blast zone. Here's a brief recap of our preliminary results from last week with the programming module subsystem. This week we created 5 preliminary designs, and each comprised of the 4 subsystems. We used a brainstorming method to develop multiple design ideas for each subsystem and combine them in various combinations.
Our first subsystem features high target accuracy. Our drawer slides slide out and deposit the pills into the red zone. The Sentinel subsystem will push the dog bone into the EMP zone, and our programming module subsystem is very similar to what we used last week. The Morpheus subsystem is triggered by a mousetrap, and then all of our subsystems will be retracted using a DC motor to egress from the blast zone.
This design is very similar to the previous one, except instead of the drawer slides, we have a scissor arm mechanism to bring the pill subsystem out and to grab Morpheus at the same time. An advantage of this would be that we could grab Morpheus while we are depositing the pills, but there is a serious lack of stability, and so that is a serious negative. This is similar to the last one, except instead of just pushing the Sentinel, we have a tube to slap the Sentinel out of our zone and hopefully into an opponent's home zone. And so this has the same positives and negatives as the last one, but another positive is that the Sentinel will be slapped into someone else's zone, creating a greater point gap. This design is very similar to the first, except our program module subsystem scoops the balls into our zone instead of pulling them with the uneven arms. A big con of this one is that the scooping is less advantageous than just pulling them in, because it would be more complex and it would require more string, and string is pretty much the worst.
Design 5 features 2 independent drawer slide systems, and the Sentinel subsystem features a fly swatter-like device which will swat the dog bone into the opponent's zone, taking away their points. The Morpheus subsystem is also powered by a mousetrap and will hopefully retrieve Morpheus and then be egressed using a DC motor. Design 5 also features the scooping programming module subsystem that will pull all 8 balls back into our zone.
An evaluation matrix was created to determine which final design would be best for this competition. As you can see, the first design scored the highest ranking within the 5 designs. These were ranked on several different pieces of criteria and then weighted according to their importance. The final design we chose had ranked highest in stability, target accuracy, and simplicity. Compared to other machines, this design is more stable due to the outer walls and the use of drawer slides as opposed to scissor arms. It is also more accurate due to these drawer slides. It is also more simple than other designs because multiple subsystems can use the same energy source.
On the screen you see the CAD model for the final design we chose. The Sentinel subsystem will hold back the pill subsystem and the programming module subsystems. Once the Sentinel subsystem fires, all the other subsystems will release and begin scoring points for our team. Once again, the programming modules will fire out and then retract back, scooping the balls into our zone. And the pill subsystem uses a switch to detect the red and blue zones and depositing the balls using a solenoid valve into the red zone. Once we have finished collecting points, a DC motor using strings will retract all of the subsystems back into our home zone.
Our next steps as a team are to combine all our subsystems into our final machine and continue to improve each individual subsystem. And then take that machine to compete in the final competition, finish all the reports, and most of all, stay safe. We would love to take any questions you may have.